So here we are. This is 129S. That's the right class. Good. So tonight we've got a few chapters, Chapter 8 and part of Chapter 9, and then I'll demonstrate the SQL injection, some more SQL injection in the Web Security Academy. So let's take a look at that. I have Chapter 8 here. Whenever it loads. Chapter 8. Coming up to the blazing speed of my Mac. It does slow down the Mac to be streaming, I've observed. It's generally tolerable, but it is slower. Yeah. Good. Yeah, America is also no longer rated a completely democracy. It's rated like a corrupt, damaged democracy right now on the same scale. Oh, yeah. No, but Mandiant did get purchased by Google, which surprised me. Google Cloud, which is hardly Google's leading offering, so I don't know what's going to come of it. The only comments I saw is, boy, they would have been better if Microsoft had bought them. But anyway, we'll see what Google does. But Google Cloud is like a distant third, and I don't know why you'd sell to them. It's not over yet, though. It has to get regulatory approval and stuff. It might not happen. Anyway, so we'll talk about access controls. So you need to know who is using it. So they must have authenticated themselves first. And then once you've found out who has logged in, you are supposed to have access controls. So every time they attempt to do something, you first make sure that they are in fact logged in with an account that has those privileges. Every request has to be tested, and it is very, very common that there are some actions that do not test to make sure who you are, and that's the common vulnerability called insecure direct object access, where someone can access that function and execute it without in fact being logged into an appropriate account. So there are various ways this can go wrong. Vertical privilege escalation is the kind you normally think of, where you escalate from a user up to administrator. Horizontal privilege escalation is where you log in from one user to another user at the same level of privilege, which is, of course, also not good. Then you get in somebody else's email, somebody else's bank account, things like that. And then there's business logic exploitation, where it is not that you gain the identity of another user, but you do things you should not be able to do. For example, you order a product, and then you're supposed to pay for it, and then you're supposed to give shipping instructions, but maybe you just skip the pay part and just go right to the shipping instructions instead. That's the kind of thing. If you're allowed to do things in a illogical manner, skipping over steps and therefore having an unexpected result. So that's what I talked about. Completely unprotected functionality is where it doesn't check anything. It doesn't even check that you're logged in at all. Just anybody that goes to this URL is able to do whatever that URL is for. That's unsecured direct object access. And so you might have an administration menu here, and if you know the right URL, you can just open it and then execute administrative actions because it doesn't check to make sure you've logged in as an administrator. So often the app will not contain a link to the URL. You might find things in the code, like here, it's going to add an item in what looks like a JavaScript page. It's going to add this, but it doesn't give you the whole URL, it just gives you a part of it. It's going to build it. And you might have this sort of thing where there's a parameter in the URL that's used to say which document to show. And so in this case, they might not have any access control on it, so anybody with the document ID can view the document. And the main reason why this happens, along with pretty much everything in this course, is because you have developers developing parts of a website, then adding part of a website, then connecting to some third-party service, and at some point somebody's trying to get something working, and they really don't have access to the authentication system. It's on a different server, it's not easy to integrate, and so they just don't bother. All right. So you might be able to predict the document identifiers if it's just incrementing numbers and easily find other documents you weren't supposed to see. And of course, if you're putting parameters in the URL, those are pretty easy to find because they go in server logs and they go in the refer on pages, the next page you go to, and so on. So here's the sort of multi-stage function: select new user, department, role, enter username and password. You might enforce access control just to get here, and then when they go here, just assume that the only way they could get there was to come from here, and therefore they must have already logged in. But you have to keep checking at every step because, of course, you can't be sure of that. Someone might have figured out what this URL is and jumped straight to it without going through the steps before. Another one is where you have static URLs. For example, people might pay for a book and then they download a book, but you really don't bother to make sure that they've logged in. You just assume that they won't figure out this number if they didn't pay for the book. But the problem is, after one person pays for the book, they can then, email this and put it on public forums and let other people just download the book from there. So that's insecure direct object access again. All right. And so you can also restrict paths. Instead of restricting just one URL, you can say only administrators can go into this path. The problem is, if you do that in a configuration file for something like the Apache server, then it's very easy to restrict only get, but not restrict things like post and head. There are different verbs, so often changing the verb will let you get at something you're not supposed to be able to do. And this is something they call verb tampering. So the access control might only apply to post, but get might let you in. Head is a method that does not show you the content of a page. It shows you only the header, but you can use it to probe to see if you can get to an area you're not supposed to get to. And another thing that happens, which is very strange, is you can just misspell an HTTP method, like a get with two T's. And when you do that, it will often default to get, but it may not match in the security parameter. So it will not be recognized as a get, and the security restrictions will not be applied to it. So here's other ways to do it. You have parameter-based, referrer-based, and location-based access control, and all of these are insecure. In a parameter-based, you'll have a parameter somewhere, like in the URL or perhaps in a cookie, that says admin equals true, admin equals false. You can just add that parameter, and now you're the admin. This is, again, letting something that came from the client to determine your security level, which is an error, unless what came from the client is something signed and encrypted that the user cannot modify. You can use the referrer to see if they came from a page of yours, but of course you can't trust that. You can just change the referrer field to be anything you want. And you can try to have location-based access control, where it takes your IP address and tries to figure out what country you're in and only lets people from the right country in, which is what they do to prevent people from certain areas from going to sports events and such. The problem is you can bypass that a lot of ways. All you need is a proxy or a VPN that redirects your traffic from another location, or you can switch your mobile device to go through the cellular phone network, which comes out in a different location, or you can directly manipulate your phone to lie about where it is. So you can compare the results for two user accounts to see this sort of thing. So here's an example where you go to you do a sitemap, browse around through a page, logged in as one person, and then logged in as another person, and Burp can compare them and then highlight the differences. So one of these, I think the blue one, is things that are deleted, and the yellow is stuff that's added, and the orange is stuff that's modified. So here you see, at the top, they see a name of admin, and at the bottom they don't. So when you're logged in as the administrator, you see an admin on this page, and when you're not logged in as administrator, you don't. So that's not a bad thing. That's reasonable. But, so the low privilege user is not allowed to get to the admin page. When they try, they get an error message, not authorized, but the administrator gets in. So this, again, looks the way it should, but they found a function to list users, and that function does not verify that you've logged in. So even when you're logged in not as the administrator, you can still access that function. So they had some areas that were controlled with access control and other areas that were not. All right, so you can test these methods. You might be able to see a pattern in the names of things. And so you walk through the app, logged in as an administrator, note the URL of high privileged things, then log in as a low privileged user and go back there to see if you can do it. If you can see a pattern in the activities, you can guess the URLs of pages you haven't seen. So log in as administrator, try other methods like post, get, head, and a misspelled request verb, and see what happens. In general, you should not assume that users don't know a URL even if it has a complicated random number in it. The problem is there are ways to find it, and once anybody does find it, they can spread it around. So this is like hiding a key under the mat. This is called security through obscurity, where you hide something, but there's no actual barrier. So you're just hoping that they won't find it. And that is better than no security at all, but it's weak. It's brittle. Once it's broken, it's gone. Don't trust things that came from the user. Don't assume they go to through your pages in sequence. And don't assume they didn't tamper with the data. So you have to check your access control for each function in the application and use a central component to verify the access control. Don't keep copying and pasting copies of code, then it won't all be the same. There should just be a central function to authenticate and a central function to check your privileges. Like in a Windows domain, you have a domain controller that does that, and nobody else does. Every time you try to access anything, it checks with the domain controller to make sure who you are and what you're allowed to do. So you can also restrict by IP address in addition to login, which is fairly common for things like administration pages on firewalls and such. And you can use other techniques as sort of a second factor here. So don't trust anything that came from the client. And you might require them to re-authenticate or switch to two-factor for really critical things. And you should log high-privileged actions that are performed. So if somebody does defeat your access control and do high-privileged things, you can go back and see what damage was done. All right, so like I say, central access control, one central server handling this is much better. It's more maintainable. It's more adaptable. Now, if you add some new feature, you just say, okay, well, use our standard API to check who people are, and then there's just a standard thing to do. You do the same thing everywhere. And then, of course, you can update it and change it as needed. It's much better than having a bunch of ad hoc mechanisms that aren't all the same and aren't all being updated at the same time. And so you may have a complicated matrix where you've got different kinds of people, from an auditor and a normal user, an administrator, and all these different roles and all these different parts of the website. And some people can go here and some people can go there. And this is the sort of thing you have in a complicated business logic. All right. And in the spirit of that the video I played last time, I thought this was kind of fun. This is a kind of fun trick, although it probably has no practical importance. But if you're using PHP and you use this comparison, MD5 of the password should equal this. In fact, there are a whole bunch of passwords that will satisfy this condition because PHP is a weakly typed language. So if you have a string that starts with 0E and has only numbers, not letters after that, it is interpreted as a number. 0 times 10 to the 199 trillion, whatever this is. So anything that fits that pattern is all equal. So you can log in with this password, even though its hash is completely different, 0E460, because anything will be interpreted this way. The correct fix for this is you had to have 3 equal signs here, not 2. 2 equal signs means it evaluates this and evaluates that and compares them. 3 equal signs means it must match both in type and value, which is what you actually want here. That must be exactly that string. So that's another one of those awful things in weakly typed languages where the computer is guessing what you mean. I started out with languages like C, where you just declare all your variables. This is an integer, this is a string, this is a character, and there's no arguing about it. But in these weakly typed languages, it tries to guess what you mean, and therefore it might guess wrong. All right, so let's try a Kahoot here. And I've got them here. Got to get past this. There we go. That would be chapter 8. I said, okay, it's moving. Library. Well, 129S, chapter 8. There we go. Well, maybe that's everybody that's coming. Apparently so. All right. Okay, accessing pages out of order. All right, that's logic exploitation, defeating the business logic. All right, how about reading somebody else's email? It's horizontal escalation, which is kind of an oxymoron. Escalation implies vertical movement, but anyway, that's the term that's used. All right, how about security through obscurity? Yep, that's unprotected functionality. Anybody that finds it can use it. And what would a proxy server bypass? Yep, it makes you appear to be in a different location. All right, that could be Judy or Jordan. And I think there are in fact two Jordans too. So you'll have to give me more information there to get your points.